Армысыздар, құрметті қонақтар, құрметті ұстаздар, құрметті студенттер, бұқаралық ақпарат құралдарының өкілдері. Барлықтарыңызды бүгін халықаралық білім беру корпорациясында көргеніңізге қуаныштымыз. Біздің бүгін ерекше қонағымыз Патрик Шумахер, Заххадид архитектстің басшысы. Жалпы бізге осындай эксклюзивті түрде ашық дәрісін беруге келіп отыр. Сондықтан барлықтарыңызды лекцияны бастамас бұрын ұялы телефондарыңызды дыбыссыз режимге ауыстырып, немесе өшіріп қоюларыңызды сұраймыз. Сұрақтарға кейін қосымша уақыт беріледі. Сондықтан дәріс кезінде кішкене сабырлық сақтап, жақсылап тыңдап, дұрыс қошемет көрсетейік. Келістік қой, Всем добрый день еще раз. Всех приветствуем, всех наших партнеров, уважаемых, наших представителей СМИ, наши уважаемые профессора, наши студенты. У нас сегодня замечательный гость. Вы все его прекрасно знаете в мире архитектуры. Так что, прежде чем начать, просим всех выключить телефоны, либо поставить на беззвучный режим. В зале идет запись. Для вопросов будет отдельно потом время уделено. Так что всем хорошего времяпровождения, отличных информаций, инсайтов получить. Я передаю слово Мади. Пожалуйста.
Ladies and gentlemen, esteemed guests, colleagues and students, it's an honor and privilege to welcome you today at KazGasa for a truly special occasion. We're gathered here to hear from one of the most influential voices in contemporary architecture, Patrik Schumacher, who is a principal of Zaha Architects and a leading theorist and a practitioner of parametricism. Architecture today is evolving at an unprecedented pace, shaped by new technologies, computational design, and ever-growing need for sustainable and adaptive environments. What once seemed impossible is now becoming a reality, and a few firms embody this transformation as powerfully as Zaha Architects. Their projects push the boundaries of form, function, and aesthetics, redefining what architecture can be in the 21st century. Patrik Schumacher has been at the forefront of this evolution, championing parametric design as a new paradigm that responds dynamically to complex urban and environmental challenges. His work and thought leadership continue to inspire architects, designers, and scholars worldwide, just like we are. We're incredibly excited to have him here with us today to share his vision, insights, and groundbreaking work. Please join me in welcoming Patrik Schumacher.
No, good to see you guys. Thank you, Marty. I'm very happy to be here. Thanks for a wonderful hospitality. I feel very welcome here. I'm very happy to visit Kazakhstan, Almaty. I had a wonderful conference yesterday, and I hope I will come back to do some work here. So I will talk about architecture for the 21st century. You said I'm influential. I'm not so sure, and maybe I'm notorious, but the influence is yet to materialize. It feels quite lonely sometimes in terms of the work we're doing. There's not enough emulation and dissemination, let's say. So in terms of the world of parametricism, it's recognizable as also internally very diverse in terms of the morphology, materials, and patterning and spatialities which we develop. It's rich and diverse, and I compare to the endless forms of nature. So I would say that within parametricism, the diversity and versatility of formal strategies you can deploy and the way these forms are adaptive, it's richer and more versatile than all the previous styles of architecture put together. Because sometimes I'm asked, why do you want everybody to work within parametricism? Doesn't this become too much the same? I said, no, that's a real takeoff of further diversity and versatility. Because the space of exploration for creative and unique solutions in parametricism is at least 1,000 times larger than, for instance, modernism or any of the other retro styles we still work with. So it is nothing, it's all about opening up and working together and exploring together that new paradigm of architecture. And I think then it will really take off and flourish and show its versatility. The moment we're we're a way too small group, so we need everybody's help to develop this paradigm forward. This is some of the projects we've been putting out. I won't detail it, but I want to show you this. This is nearly 20 years ago. I came to Almaty and we made some sketches for a major site right next to the Square of the Republic. So parametrism has been around. This was already kind of over 10 years into the development of parametricism, and by now we are 30 years in. This was too ambitious years aside. Then we had another go at this complex. It became a bit smaller, and mixed-use development anyway. It didn't happen, unfortunately. We then, more or less a year later, at the same time, we made this proposal for the National Library of Kazakhstan in Astana. It encapsulates a beautiful garden and has a big atrium at the peak, as you can see here, and a wonderful set of spaces to communicate. This is our architecture where we love to layer spaces vertically and use full three-dimensionality to have intervisibility between all spaces to enhance communication. Finally, maybe it's slightly more restrained, our first project in Kazakhstan. It's in Astana, also very close to the center, the National Bank of Kazakhstan. And we're integrating that with the landscape. The facade is all limestone, but the main feature is this atrium, which connects you also to the exterior and allows all the departments and workers to intercommunicate visually to see what's going on at all times. It's panoramic elevators, various terraces, etc. It's under construction, and we're very proud to contribute to Kazakhstan with this first project. Now I also wanted to show, I'm not going to show the Baku project, I will come in later in the lecture, which is close by, so the region, but this is a project we're doing in Tashkent, in fact, New Tashkent in Uzbekistan. It's a cultural building and a research and conference center. And the exterior expression is the structure, which is at the same time wind funnels for natural ventilation. So when the sun hits the surface, it warms up and pulls the air out and through. Well, I think it's a wonderful place, also integrating with landscape design. And this is the principle of the wind tower. And again, double and triple height spaces for visual communication, inside, outside, across the various levels. I think it's a wonderful project, and after Baku in the region, maybe another major landmark for us. I think it's quite inspiring. So, we will talk a lot about tectonism, which is the latest stage of parametricism, but I thought I'd just introduce parametricism a little bit. This article was published in 2009, so it's been a while, 16 years ago. The year before that, in 2008, I launched parametricism at the Venice Biennale with a conference and an programmatic article in the catalog. The year before, I started to talk about it in smart geometry conferences, etc. But at that time, it was the actual development of parametricism was already nearly 15 years in the works. But it didn't have a name. And I thought, after 15 years of coherent work, and it was spreading throughout researchers and universities and elite schools around some key spaces, and we've been developing it very coherently at the AA in London and at the studio. I thought this deserves a name and a program and a theoretical summary and canonization, a bit like the international style program and formalization of, in the early 1930s, after 10, 12 years of modernism, formalized this style. So I think that's the beginning of giving it a label, a flag, a manifesto. And I just wanted to, so this idea of canonizing means to look back and see what are the principles we've been adhering to, even subconsciously. What are the, let's say, what are we no longer doing in architecture? What are we avoiding and what are we always promoting? And this is what I call the negative and positive heuristics, or you can say the taboos and dogmas which canonize and define the style. So at that time I realized we are no longer doing rigid forms. We don't use cubes, cylinders, domes, pyramids, etc. These simple composition elements which Le Corbusier still thought were the main elements of architecture. And it was just about composing these. And we said, we've never used those for the last 15 years, so something is happening. We also, when you develop systems, in modernism in particular, but even in classicism, if you look at a Gothic cathedral, each bay is repeated. Repetition is a very profound and fundamental element of ordering architecture through, you know, Gothic, Renaissance, but also modernism. So simple repetition, which is extremely obvious in modernism, we stopped, never to repeat an element. And also, after modernism, there was postmodernism, which was bringing disparate elements together. It's some kind of collage attitude. Postmodernism, Charles Jencks developed the concept. Before he called it ad hocism. It was this idea of collaging, deconstructism as well, interlayering disparate elements, and they remain unrelated. So this is collage of unrelated elements, which was happening in the 80s and 90s, or let's say mostly throughout the 80s. We also said this is taboo. If you bring two elements together, different, we need to mediate. They need to resonate with each other. They need to blend from one into the other. So we're never just composing elements. Once you bring an element to another element, something happens to both elements. Okay? So no collage of unrelated elements, that's taboo. So what we realized, everything which has happened in architecture for thousands of years is taboo. So we're doing things radically different, and we have to watch out that we don't fall back. So what are we doing now on the formal level? All forms we're using, instead of there are Platonic primitives, they are parametrically malleable. They have parameters, and they take any form depending on what they get close to or where they sit. They're different primitives. When we do systems, multiple elements coming together, instead of repeating, there is transformation from one element to another. Gradual transformation, so they're differentiated systems. Okay? Which you find in nature. There are lots of examples. The honeycomb is actually, when you look closer, it's not equal cells, kind of densifying, radiating out, or snake skin, wherever. It is differentiated system. And when we bring systems together, they started to be correlated, like elements together correlated, systems to correlated. So these are the principles of parametricism. But then this is just formal principles. That's the repertoire you work with. And you realize that this has to have some meaning, has to make sense with respect to the societal tasks and the functionality demands on architecture. So there's a parallel. For instance, we don't do rigid forms, but we also, in terms of the programs, we don't think in terms of fixed stereotypes. Ideally, I mean, a lot of people still do, but in a modern society where there's a lot of variation and diversity and differentiation of social conditions, you don't repeat spaces. Every space is unique with respect to place and purpose, and if you do several of the same, you want variety. So, and because there's no social homogenization, we don't have this kind of simple repetition. And we don't segregate zones in the city and the building. They remain distinct. So these are sociological and programmatic functional differences in the contemporary society which match up here. So positively, all functions are variable event scenarios. So if you had a conference is different from another, a classroom should be different from another because the class is different in terms of composition, in terms of agenda. Everything, an apartment should be tailored and varied to the situation. So all program domains are differentiated. If you have one category of program, it comes with a lot of variety. But most importantly, when you have the different program types and systems internally differentiated, when they come together, they start to correlate and communicate with each other. So all the social events communicate with each other and influence each other relative to where they are. And I come at the end to this when I say we do a program, we should not just look at the schedule of accommodation, which is a series of items on a list you take for granted and translate into square meters. When we talk about program, we're actually simulating the events. We're bringing crowds and people into the spaces with their agendas, with their communicative relations, and simulate them and see that the spaces adapt to their dynamic interactions. That's the contemporary world. And then you can only do that if your architecture is parametric and the social scenarios are dynamic and evolving. You'll see later how this starts to look like. So these principles have been operating now. We've been working with these principles for nearly 30 years, or more than 30 years. And parametrism has a series of subsidiary styles. Tectonism, which I will talk about, is the latest style. It's a bit like modernism. Started with the white modernist. Then it became more richer. It has brutalism. It showed materiality, and there were larger structures. The structure could not be hidden anymore. And then it developed into metabolism, into high-tech. Modernism has a series of subsidiary styles. It was but the principles of modernism in the high-tech project are very similar, and they're the same fundamental principles like the early modernist. It's about separating functions, optimizing them with the components, but then each zone has internal repetition. And this is kind of separation and repetition is always happening in modernism through all, whether it's a white modernism, whether it's brutalism or high-tech. So this is, similarly, we have the principles going through, but the development of parametricism became more enriched, increasing repertoire, increasing rationality, increasing articulation. So I'm starting with this. When we started parametricism, we looked at so-called folding in architecture. That was the first slogan, the first name of what I later called parametricism. Folding. Why? The idea was that you can, instead of dissecting space with walls or boxes within boxes, you can articulate zones by making pleats and folding a single surface. And this could be adaptive. So everything, there are many projects you'll see, which are just about folding a surface. That's the main way. So these are the kind of projects which are about splicing, cutting, folding, pleating a surface, and generating architecture through this. No walls, no enclosures, open folding surface. A project like this, the continuously looping folding surface going around, that's the way you can create an architecture, and it's very open and fluid. And you're using elements like the stairs becomes the lighting. So the purpose of this, you have a very complex space, but it's not filled with a clutter of composed elements. It's just one flow of systems, so you can focus on the space. And it's not, you're not distracted with all sorts of elements and different colors which are irrelevant to the flow of the space. The space is more complex, but the articulation of architecture becomes much more simplified and fluid. And then you also, this continuous folding of surfaces, you can do it in different materials, etc. So instead of adding a staircase and a handrail, the same surface does everything. Instead of adding, ceiling lights and acoustic things, seats are just rippling of a surface. That's foldism. The next stage was, okay, we need sometimes to make enclosures. This is the idea of blobs, blobism. And what you can do architecture like this. And what's the advantage? Instead of having room A next to room B, and each room is closed, or 3 rooms inside a larger room, nesting, that was the only logic by which you can organize architecture. Until, let's say, deconstructism, where it starts to change. But what you can do here, there's degree of separating out. There's an overall space. It's not just either you're in the big space or in smaller space. You're in a larger space which has subsidiary parts. Degrees of articulation. This is more separate, most separate. This is relatively quite separate. But it's still continuous flow of space. And these nearly fuse. And that's you have suddenly, you go from a set theory where you say separate or nesting or maybe intersecting, which was the only introduced in the 1980s through deconstructivism, that you have intersecting spaces. We're going beyond that. You can have intersecting, that you can have fuzzy logic, degrees of being in one space and another, etc. And we can have architectural articulation of this. So this blobism, we have quite a few projects. You can see they kind of fuse, and there's an open flow of elements. Negative and positive blobs, blobism. Also applies to furniture, applies to everything. The style of parametricism and its different subsidiary styles, they're all universal, applicable to the totality of the phenomenal world. So you can do that in urbanism, I will show you, in architecture, interior design, product design, fashion design, if you like. Everything. It's total. So we as a discipline, I'm very much thinking like the Bauhaus, unifying across all design disciplines so that everything you ever touch, see, or even interfacing, including graphic design and interaction design, everything you ever encounter in your life was designed by a colleague. We have, as a design discipline, universal and exclusive competency with respect to everything you ever touch, including landscape, because we have landscape designers. And there will be parametricism across all of these domains. And since every designer is looking at design, everything new, totally connected, it's a world architecture, world design, when you make a strong statement and make a reference, it will change everything which happens in the world and recreates the totality of a phenomenal world, like the Bauhaus. The Bauhaus in the early 20s made some experiment on urbanism, architecture, interior design, product design, furniture design. And Gropius and Mies, they lived to see in the 1960s the whole world, everything, transformed in the image of their research and development, including the Soviet Union, including all of Africa, including India. everywhere. This is the whole planet. So we have to do that again. So this is swarmism, where you have, so as surfaces, we have blobs, and now we have swarms of elements. It's very good for urbanism. And the swarm is a formation, a whole, which has many parts, but you don't see the parts. What you see is a global form which compresses, stretches, transforms. These elements don't have to touch, but they are connected through logic, computational logic. So this is, what is beautiful about this, you can take an existing urban fabric, you can connect it and continue, and then dramatically change scale, openings, and it is coherent. Rather than currently, every development on the world in the last 40 years is totally incoherent. Have you ever seen a city which has any sense of identity, beauty, coherency in the last 40 years? No. I call this garbage spill urbanization. That's what we say is taboo. The agglomeration of unrelated elements, which came after modernism. And it's universal. So the last beautiful urban spaces were done in modernism. You know, White Tel Aviv, Brasilia, Jandiga, the Art Deco district in Miami. You can recognize these as beautiful. Since then, we only have visual chaos, without exception, on the whole planet. And I think that shouldn't continue. We know how to overcome this, but we need everybody to participate. Like everybody in the 1960s was participating in modernism. Everybody in the 2020s must participate in parametricism and totalism, and should, because everything else is retro. Everything else is you designing now. Most of our colleagues, unfortunately, designing as they could have designed 80 years ago. There's no advance. And that means, why do we have an academic discipline? Why do you have universities? Why are we just apprenticeship and craft? That's my challenge. So this is parametric urbanism. We won major competitions. I showed that yesterday, the whole build-up after 20 years of this master plan. Because when you come to a client, you explain that you, instead of making 100 same blocks, you can make 100 different blocks. So you can offer the market anything from small, medium to large. And you can make a coherent, connective thing, and the translation could be different. We're winning this competition, we're winning this competition, we're winning this competition, we're winning all these competitions. Now, and this has been fully built out. I don't have the images how it looks like now. It works very well. That's what our cities should look like. And they have a new identity, but they're adaptive to locality. And we're using tools, of course, to do this. We're using sophisticated tools. Instead of having different zones separated, we want to bring them together, overlap them, but we can do that in intricate ways. And so in terms of functional separation, like Le Corbusier's plan, the business district, the residential district, the logistics, the factories, all separate, internally all repetition. That's not how society works. We have now live, work, continuous communication, integration, and so on. So then you have a model like this, and then you can script tectonic translations onto this vector field, and this is one. You can do two, you can do three. Anyway, and that's in the end something you can generate. Each liquid, each color, you can have translate differently the vector fields, density, directionality, etc., into different morphology parameters. So these are the kind of urban textures we want to generate. And they are open-ended, but they have coherency and legibility. Okay, now, the history of this is quite interesting. So this started in the 92, 93. Columbia University was the first, 94. Digital Studio, everybody on. Then came the AA, then came Harvard, then came Yale, then came SCIAC, and the Bartlett, and so on. So and every architect of this generation realized that's what we have to work on. They were doing different things. In 92, in 93, everybody was working on this. It was a total takeover, it was wonderful. And that means we accelerated. The problem was that in 2008, the financial crisis blew that up to some extent. All these wonderful works were cancelled, all these projects in Europe, in Dubai, and everywhere. Then we had Arab Spring, and so there were political upheavals and socio-economic upheavals which stopped this. And then there was a change in the mind of the profession, and it was Occupy movement and social justice and anti-capitalism and architectural schools and education and biennales. They went somewhere else. They were highly politicized. And for this group of architects, the dynamism was slight. We continued, but we didn't grow as a movement. But what I find interesting, we as Zardin Architects and some other firms continued, and we did more and more projects, and also some commercial forms, particularly in China, Fuxas Shenzhen Airport, SOM Mumbai Airport, many of our large projects, Beijing Airport, large projects, large city. But in the overall discipline, it's still a drop in the ocean. But it evolved, we matured. We learned how to use structural integration. We used environmental engineering integration. We learned many things. We learned how to apply this to all scales and programs. So we grew, but it was a narrow band. And I said, we weren't influential enough. But what I find fascinating, and that's why I show this, when AI came on recently, so if you go to the Zine Awards or something, there's no parametrism. It's all retro, retro, retro. But when AI came on, suddenly we realized, first of all, we could use it. There was so much of our stuff out there in the web that you can generate prompts with saying, Za need urbanism, Za need museum, and you can generate all of this. So it was wonderful. So we generated all this 100 new projects in an afternoon by myself. And we could do it because the internet, all these, DALI 2 was a breakthrough, is full of our references. And so that was great, and we're using it. And I will come to this, I show it here now, but the most recent of our work, tectonism, is much more sophisticated interaging engineering logic. So these could get poise, balance, perspective, light and shadow right, and understood parametricism. We also could use it from urbanism. We now kind of also train our own models, neural networks to integrate. And we can generate these urbanism models rapidly in multiple variations, feeding it with our own references, the big stable diffusion model, our model. So we can parametricism proliferate. And we can mix degrees of models. So I mean, because we have done about 100 master plans, we can feed them into the AI and then generate 1,000 more. That's why we're going to could do wonderful work, for instance, in Almaty, where you have to, how do you design? Because we want to visualize the final feel and architecture in a building like this. We can do it. Anyway, so and as I saw earlier, we can do that even by programming out with color. This is water, this is green, this is morphology, and it picks that color coding up and runs with it architecturally. But what I find fascinating, if you Google AI architecture without any prejudice, without saying parametricism, anything, you just Google AI architecture, what do you see? It's 75–80% parametricism. So something is strange. The world is ignoring us. Schools of architecture are ignoring us. But when young architects show their desire, what they want, it's that. And that gave me a lot of hope. And so it's just, everybody wants parametricism. But it's hard to do it. So they would love to do it. Maybe in school they can't do it, in the professional world they can do it, but at home after hours, they can now visualize it. And and if you look particular at all these people who want to now teach you how to prompt well in Midjourney and so on and different things, look at these. In particular, all those teaching programs. What do you see? And I think that gave me hope that this is coming. This will take over. It must. And I'm trying some things more with technoism. But the problem is, at this stage, there's no engineering intelligence. So these models can get perspective right, they can get light and shadow right, they can even tessellate a body. They've learned on 500 and more examples of parametricism, but the current stage of parametricism, I will talk later, which I call tectonism, they can't do it yet. There's not enough reference, they not have learned that. So there is a lot of nonsense, missing members, because there's the coherency requirement of structural models is higher. That's only temporary like this, because there's not been this kind of learning curve. But that was a challenge for me, and I will show later how we now training AI to do this as well. I mean, if you look close at these, they're very incoherent. They're missing members, missing elements. And also these attempts, which I tried, they don't have structural logic, really. It's kind of pretend. Anyway, so that leads me to this recent style. The last 10, 15 years, we worked on tectonism. They're not many build examples, so AI cannot learn it yet. And I will now go into this latest stage of parametricism. And you can see it looks even more versatile and rich than the world of parametricism. And the forms, instead of just being NURB surfaces or blobs or subdivision surfaces, let's say certain Maya geometries, they have, anticlastic, tensile, meaning minimal surfaces, active bending, inflatable surfaces, compression only surfaces, conic, developable surfaces, all kind of technical range of geometries is much more rich and diverse, and we can have an eye for this. And then there's all these reticulations and patternings, which are coherent patterning, and before we only had gray or white. So this is the world of tectonism, which is much more rich than the earlier stages of parametricism, because there's a full integration of structural engineering, but also fabrication, robotic fabrication, etc., built into it. Structural optimization, like topology optimization, etc., and we come to this. So this is a series of my writings and books, and the latest book came out last year, Tectonism, is describing this, and that is what AI can do, and it's much harder to work on also as a designer, because you need to learn a lot of the engineering logics and a lot of the plugins into Grasshopper, let's say, but it's still very available, because it just has all these plugins have tutorials, so you have mesh relaxation, and you can form find. You don't stand there and model, you run algorithms which find the right form. And that's much more beautiful, coherent, and faster, but also has an rationality. So tectonism is the most advanced stage of parametricism and implies the expressive heightening, and that's something I'll come to, what that means, of engineering and fabrication-based form finding and optimization processes. So everything is run through engineering logics, but you can compose freely, because the big advance of this type of engineering is all prior engineering was actually constricted to Platonic forms, more or less to symmetrical composition, largely. Repetition of elements is highly irrational now if you can do more sophisticated. But here you can do very irregular plans and run a vault across this, which is fully optimized. a full equilibrium vault on a randomly free-form plan. Or you take a structure and you have run a railway, the position points are irregular, there might be a bridge hitting there, so it's totally asymmetric condition. You can run a topology optimization and resolve that beautifully in a differentiated structure which takes all of this into account, which is absolutely impossible to calculate in the traditional engineering, where you have to think about pure systems, you know, like a trussing system or Varendale system or, you know, pillar post system, etc. But these new structures are a mixture of all of those, where all connections are moment connections, etc. And pieces are partly in bending, partly in compression, etc. So with the objective to increase information richness and legibility in the built environment, I come to that. So for architects, this engineering optimization is wonderful because your buildings become lighter, eventually cheaper, etc. But what we are interested in, and I will come to that, is they have a more richer identity, unique identity, they have legibility. You can understand what's going on. You're in the building and something is happening in the structure and you see, this is the bridge hitting in. Or there's a vault and you'll see where the forces flow and it tells you, this is the entrance, the big opening. This legibility, which you cannot get in the modernism, is what I'm looking for. So this is the new world, and this is parametricism before the tectonism advance, which is a massive advance in rationality, because when we did these designs, between these surfaces, we had massive poche of bizarre structure, just doing something which we wanted for social and spatial purposes, but now we can integrate this. So what I think, this one is much more the endless forms of nature than this. So within parametricism, you can have massive advances. If you compare, for instance, high-tech, something like Hong Kong HSBC or the Centre Pompidou, and compare this to the Bauhaus of the 1920s, there's a massive advance within one paradigm. And here we're having a massive advance within a new paradigm. So tectonism matured in the last 15 years. These things take time. So again, I came out with the concept of parametrism 15 years right into the actual development. Tectonism recently formalized and canonized 15 years after its development. So we have a totality of 30 years. First 15 years, then I said parametricism. Another 15 years, I say tectonism. And there will be more coming. But it's interesting. So like high-tech is distinct from early modernism, this tectonism is also quite distinct. You can see it and notice it when you see it, and it's more diverse. Okay, so just some more examples of this. And it doesn't mean it's always super expensive. This is a simple tensile structures. And I just want to show you that we're talking here about, let's say, paradigms, methodologies, but also styles, which I think we should understand as a very profound concept. There's something very profound when you move from the Gothic into the Renaissance, into the Baroque, into neoclassicism, into eclecticism, expressivism, modernism, etc. Something is fundamental. And even in the 20th century, there was, these manifestos and books. We need to know that. We need to understand that. Because this sequence of styles is tracking socioeconomic epochs of societal development. That's my argument. So I'm talking about epochal styles. And then there are, between epochs, there are transitional styles, and then there's subsidiary styles like white modernism or functionalism, brutalism, metabolism, high-tech. These are subsidiary styles within modernism. And in parametricism, I mentioned a few subsidiary styles. foldism, blobism, swarmism, tectonism as a big step. So that's my theory of styles, but it's most important to understand that we have socioeconomic epochs. So these are the great styles of architecture. They're only the epochal styles. I'm not having here the subsidiary or transitional styles. The first architectural style was actually the Renaissance. Why am I saying this? Let's say if you have the Romanesque or medieval, there's no architecture in a sense. This is only self-built vernacular. It's craft. There's no architect, no authors. Even the Gothic cathedral, you don't know who done them. They were, they're building troops. They were contractors. They didn't design properly. They weren't a complete set of drawings. It was just starting to build, staking out and building up these arches. And they were quite sophisticated, but it's not architecture in the sense where we now know. Whereas the Renaissance, you have full-on architecture the way we know it. We recognizing Alberti, Palladio, Serlio as our colleagues. Why? Because they did complete sets of drawings. They simulated the visual impression through perspective, light and shadow, and they wrote treatises, theory of architecture. Because if you do something innovative, you have to explain why we're doing this. If you do something vernacular in the tradition, you keep doing what's always been done. There's no questions asked, no answers demanded. But if you dramatically innovate, you have to have, first of all, convince and tell people what you're going to do, because it will look different. So you have to make a full set of drawings, including the perspectives. And you have to write why this makes sense. So architecture is authors who innovate, who take full responsibility for something original and new. They present in full sets of drawings their vision, and they have a theoretical underpinning. And these are the ingredients of architecture, which didn't exist prior to Alberti. And we still do that. And that's why it's very important that, we realize it. But then the Renaissance was socioeconomically the epoch of the early capitalism in the city-states, the northern Italian city-states. It was a particular socioeconomic formation. It moved into the Baroque when you had larger organization states. For instance, France under Louis XIV, integrated nation-state and integrated economy with massive buildings like Versailles complex as a government complex. You could not design this in the Renaissance style. This is maybe another lecture. Because the Baroque can make much more integrated parts, curvature, binding things together, deep relief, colossal order for distance viewing. And you can make, the parts are asymmetric and they create massive symmetrical complexes you can comprehend. Whereas the Renaissance is very additive. So the Baroque can express the capital of a nation state like France of the 17th century, or the Vatican, which was a global institution. The Vatican was ruling across whole of Europe in many ways, and if you look at this complex of St. Peter's, that's necessarily the Baroque style is the only style it can comprehend. And then you have a whole city developments like Karlsruhe and all the absolutism. So mercantilism, absolutism is the Baroque. And then neoclassicism, the 19th century, after the French Revolution, all of that Baroque and Rococo disappeared. And you had a new society, and this is the society of neoclassicism and historicism. And they had to, first time, they have architectural competitions, and they're doing many more things. They're doing museums, ministry buildings, universities. Before it was only palaces and churches. Now there's many more things, and there's a different spirit. So that's when we have historicism, and of course, modernism is a huge different society. It's a mechanical mass production industrial society. It's the socialist revolutions after the First World War, revolution in Russia, revolution in Austria, revolution in Germany, social democracy, plus industrialization. That's modernism. So these styles make no sense in themselves. They make sense as matching up with major socioeconomic epochs, they're lining the epochal styles of architecture. And parametricism is one of those. Why? It's the whole collapse of socialist world, which was the most far-reaching and logical expression of the era of mass mechanical production Fordism. England was a socialist economy, more or less, and so on. And so you have actually the microelectronic revolution and telecommunication revolution through the 70s and 80s, which led on to Margaret Thatcher, led on to Ronald Reagan, its neoliberalism, its transformation of China through Deng Xiaoping, a re-emergence of capitalism, the breakdown of many big, even capitalist bureaucracies into a network of smaller firms, moving away from this kind of greenfield, sleeping cities and factory and office complex in the green, everything concentrating back and in the center of the city. So there's a dramatic socioeconomic transformation. And it should have an expression in the built environment and in architecture, and that's parametricism. It has, of course, then a series of subsidiary styles, so wherever you move from these big revolutions, you can't get it right immediately. There's some kind of brainstorming, a revolutionary searching period. So you have at the end of, for instance, neo-historicism, you have actually eclecticism, where you start collaging these things, or you have Art Nouveau and Expressionism, and then modernism comes in. So you have very short, this is a 10-year period, 15, 20-year period of transitional styles before you have 60 years of modernism. And similarly, this transformation to parametricism wasn't overnight. There was postmodernism, about 10, 15 years, and deconstructivism for about 10 years. And then we established this. The problem is that this hasn't yet taken over the world like this did. So this is the world, when Fordism, this is under modernism, mechanical mass production, they can only produce millions of the same thing. And the whole economy is maybe 5 things: a car, a prefabricated house, a washing machine, maybe a packaged holiday, industrialized food. I mean, I grew up like this in the 60s. So they were going to 5 to 10 things and produced en masse, which means everybody will have the same standard of living. It's called the universal consumption standard. It means sociological something. It's all because of the prosperity gains were massive. In Germany in the 1960s, everybody of 60 million had that car, that house, that flowing water, that television with 1 channel and then soon 2 channels, a packaged holiday, industrial food, and everybody the same. There's no point in having 5 cars. There's no point in having, eating kind of 25 meals. So it means physically you have to have an egalitarian society. And but now we have 1,000 TV channels, right? And it's a totally different thing. It's huge differentiation of products. So suddenly it makes sense to have a lot of sociological differentiation, a lot of income differentiation, a lot of dynamism. And where are these people now, which used to be here? What are they doing? They're doing research development, marketing, finance, reprogramming the robots. This technology, you could not absorb many innovations. You have a new idea? No, we're going to do another 5 million of this before this plant is, it's all fixed. Here, every day you can have an innovation and reproduce it. Or even more dramatically, software as a service, a new app, a new update. Every minute you can have a new product brought to billions of people. So it pays everybody working in the knowledge economy on innovation and so on. Where are they going to work? In the cities. How are they going to work? In teams, connecting up, because a new product means you have to look at marketing, new material research, new science, new financing mechanisms, new advertising, promoting and marketing. So you need to connect across. Before this was, for 30 years you do the same thing. You don't have to communicate. Bang, 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 bang. in these bureaucracies. Now it's network, communication, collaboration, networks of companies. So it's a totally different world, and the architecture looks different. And that's a city, not this kind of modernist Brasilia or something. And yeah, it's R&D, finance, marketing, etc., continuously new. And if you're not in the center of things, seeing what everybody else is doing in the company, or other companies, going in the evening to this exhibition, to this launch, to this conference, and staying in the pub and debating, the next morning you didn't get all these new inputs. So what you're doing this week, potentially wasting your time, because you're not updated. You need continuous update. Everybody connecting to everybody else to update. Because if you haven't, noticed the latest release of OpenAI, the reasoning version, you're wasting your time. So you need to, instead of everybody's work is recalibrated continuously with respect to nearly everybody else. That's communication, communication, communication. We come to that. But also, we're looking different. Because now everybody is different specialists. There are the scientists, the engineers, the artists. You need all of them. The finance, the bankers, the entrepreneurs, the startups, the IT. In the crowd, you need to be able to spot them, and you do. So I'm talking about the semiology of the fashion system. And you have to calibrate. How do you want to appear? You don't want to be mixed up with an investor or banker. Nor would you want to be, nor would you want to be mixed up with an engineer. So you have to kind of find, and you want to express something different. Anyway, so and you want to reinvent yourself. And the office starts to look like this. In some offices, this is Google office. And they also are differently organized. The teams continuous transformation, shifting, revolving. They're not separate. You belong to several teams at the same time with a different degree. The fuzzy logic, this kind of blobism comes through. Instead of strictly nesting, you have intersecting and overlapping. You have these kind of spaces where you both overlap and degrees of belonging and fuzziness. So this is the kind of models, and it's dynamic. We're moving from here to here. This is a project we're doing, for instance, for Sberbank Technology Center in Moscow. Banks are IT companies now as well, to some extent. And that's the kind of world we need to develop. And that's where the prosperity gains are. That's what you have to participate in. And these are the kind of spaces, inter-awareness, inter-visibility. This is the project we've done in Beijing. Our own office isn't there. There's co-working spaces. There's lots of restaurants and bars and offices and retail. And you can see what's going on. Okay. This is my book. I don't want to go into detail here of this. I've seen this, so I'm a bit repeating this. So I've been throwing this together. Okay, so just aside. So as I said, tectonism has been a while in the going, and it actually the first within parametrism, the first glimpses started already in 2000. So it's not all my invention. I'm the one who's kind of a synthesizer and productizer and promoter, and Frei Otto became interesting again. I was actually Frei Otto student in the 80s in Stuttgart, because this is form finding. He was also some earlier who used algorithms, but this seems to be something kind of separate. Architecture moved somewhere else. It moved modernism, postmodernism, deconstructivism, and so on. Frei Otto was forgotten. But then we rediscovered him. And then it's very fundamental to these form-finding processes for tectonism. You see here these shells. They're very adaptive. We have 4 stations in Innsbruck. Underground, close to a bridge, on the hill, on top. So it's one principle, but it's parametric variation. Usually, say, the stations, now you do a train station, it's repetition. This isn't, it's a set of principles, parametric variation. And they're also shell structures, so they're optimized. And then also, instead of cluttering details, plugging on a drainage pipe or this and that, The drainage is just one of the seams opening up a bit, so you don't clutter the thing. And you have here a kind of correlation between two systems. The concrete platform and undercroft and the top. They have some different logic, but they correlate, they relate to each other. They're not separate, they have to correlate. We started this early on, 15 years ago, carbon fiber shells, tensile structures. So this is the beginnings of tectonism. And again, we have somebody like Mark Burry, so it's not only us, and Lars Byberg, so it's been going for a long time. I mean, Mark Burry, who was the architect computationally completing the Sagrada Familia of Gaudi. And even somebody like Reiser, Atlas of Novel Tectonics. So it also shows digital tectonics, novel tectonics. These phrases of tectonics were swinging around in the last 15 years, so that's why I picked up the name tectonism. It was the desire of parametrism relating to the tectonic. And these are studies we've done many years ago at Vienna University. So instead of having a shell like, for instance, Foster has parametric tools. He did the great roof over the British Library. But when you look at it, he uses it to smoothen out. So everything is used as homogeneous as possible. Whereas we love that this is different, open, instead of ribs, very close web, gridded, tensile shell. So under this you can imagine many different subsidiary spaces, different zones, but not separated by walls. But you can orient, use that ceiling and space to differentiate an event in different subsidiary spaces. But the concept of tectonics as some kind of heightened artistic, inverted commas, expression of structural logics, fabrication logics, material logics is a very old concept in the history of architecture. And I do like that. I want to build on this because we're doing tectonics in a new way. Parametric tectonics, tectonism. And of course, I looked at these. They're wonderful, they're structurally optimized and super high performance structures, but they also at the same time become ornament. And that's what we're talking about. Ornament is actually semiological expression. This kind of styling of and giving identity and character to the different spaces. That's a task for architecture too, not only technical. But what we've done, for instance, you have these kind of bizarre hybrids of Viollet-le-Duc, or somebody like Frank Lloyd Wright. So we have these principles or engineering parts. So we're using structural form finding and optimization as one major part, but also environmental engineering, and then fabrication constraints, how to make things. Whether you're casting, or whether you are hot wire cutting the mold for casting, or milling the mold for casting. This all implies different geometries, where you use tensile structures, etc., etc. So what kind of fabrication you do? And what is interesting for the first to realize, I said it earlier, so some of these walls, they're compression-only walls. Eventually, the horizontal forces have to be taken out by, what do you call this? Frames on the outside. But they only could do that traditionally by making perfect symmetry, because this is an equilibrium composition. And even you can actually learn this when you read Palladio, that symmetry in all buildings is a structural necessity at that time, not only in these walls. Because if you build a building and you have asymmetry, put a tower here, you have differential settling of the foundations, and the building will crack up because you can't calculate. So the symmetry was and asymmetric building was just, we have cracks all over the place. They will break up, they fall apart. So some of these are, formalized as an aesthetic, structural logic, symmetry, proportion. What is proportion? Proportion is, of course, that you have the height to length of a column, that you have spans, maximum spans, and depth of beam, or etc., etc. So all of the symmetry and proportions of classical architecture are aestheticized structural logics. Now we can do this. You can do any free form because we need to compose the spaces in complex relations, and it would be really a hindrance for a versatile and adaptive design that we have to make everything symmetrical because the institutions are not symmetrical. There's no mirroring over of spaces. It makes no sense. So, but now we can do this. What is wonderful, it also calculates each stone optimizing, and you can see how these slender these shells are. These marble shells, they have no bonding. Just pure compression. They're pure equilibrium. If you go to this model and you kick out 2 or 3 stones, the whole thing will rain down. And there are also ones which I don't have here, compression and tension. There's a loop. And if you go in and cut this, you can learn from the traditional, but we can do it much more varied. Or if you look at waffle slabs, or any concrete, even the laying of reinforcement, all traditional engineering is obsolete and irrational because it's inefficient. You have to follow the forces. If you put columns in the corner, why do you have a waffle grid? Why do you have reinforcement going in straight lines? You're wasting a lot of material. You also can thin out in the center and bend. So this is what we have to do. And isn't that way more beautiful? And doesn't it tell you where the column will be and where the opening will be? So it's more legible and orienting. And you can run this across a shell also. So we have these kind of optimization of stress, primary stress lines. And that's what we should use. And then this is a kind of 3 high-pass connected up based on a Candela model, but using this. And then using the stress analysis to layer those areas which have more stress in 2 or 3 or single layer. But isn't it more elegant and beautiful? Wouldn't you cringe if you had to impose a rectilinear grid on this? We have a sensibility for that. So that's tectonism. If you look at this chair, it's a super, here we have fabrication, we're doing 3D printing, so we are not totally unconstrained. It's the whole science. 3D printing, particularly concrete printing, there's an enormous amount of constraints, and I come to this, but it's less constraints than we usually would have. So we can super optimize. So we take a form, the functional form, we then kind of stress, relax, and optimize the shell form. Then we can run structural optimization on that surface for the reticulation. And then there are different ways of translating this. For instance, thinning out versus thickening up, plus degrees of perforation. You could do one or the other. So there's enormous amount of creativity in the translation. So it's not, it's not never automatic, but you can play with it. And then you get something like this. And then you can print that in plastic or in aluminum, and it's the strongest and lightest chair you could ever have. But of course, there's other versions you can further optimize. You can do something similar to larger structures, but then the fabrication sort of printing is more rationalized. It's straight lines and developable surfaces, but they'll correlate and resonate. So similarly with this shell, but then the first 2 steps are the same: shell optimization, reticulation optimization, and then there's a fabrication translation into straight line and developable surfaces for the holes. Anyway, for instance, towers. I guess you've all learned that. It might be still on the curriculum, but you say, okay, in a way, up to a certain height, you only need a framework. Then you need to have a core. and framework, then you need to start putting outriggers, and at a certain height you flip into exoskeleton, meaning you use the outer surface like a tube. Now, I'm saying there is a fundamental flaw here, which is the thinking in pure systems. You can take this diagram upside down, and it tells you already how absurd it is. Because the forces accumulate exponentially, wind forces and weight forces. And that's one thing. Of course, you do that by making the columns here much thicker and thinner there, but also the system separation is wrong. I'm proposing where you start with the tube and move into the outrigger and then into framing, and you can also phase change systems. So that's what these kind of things we've been doing. And you cannot flip that on top, around. So and these are still crystalline, they're not kind of optimized, there's still symmetry, but it's a step. Or these kind of projects. And this way you can also then differentiate the product. 3 flats, 2 flats, 1 flat per floor. You can open up the column and get much more filigree and light on top. And you get much more, let's say, framing action in the bottom. The other thing is when you do exoskeletons, you can release enormous amount of internal visual connection and freedom. So the tower, you should actually be like a vertical street instead of everything separate, floor by floor. And even on the floor through a central core, separating the rooms. Everything is segregated. You're in a building with 10,000 people and you all disappear in a corridor and never see each other. When you put the exoskeleton, run panoramic elevators, you can see what's going on. You're flying over the restaurant, the bar, the cafe, the conferencing, etc. The lobby, you keep seeing things. You look back into the urban spaces, etc., etc. This is the kind of thing we're going to do. Anyway, so many examples of this. So you're doing this kind of shell optimization. We have reticulation. And this is where you can start have an artistic, inverted commas. You have repertoire. You can translate this in extruded ribs, more, less, pleats. You can go into openings as well. And you can have a whole variety of characterful differentiation. And you can therefore give each space a different character. Degree, structure becomes ornament, like in all traditional architecture. And ornament is characterization, semiology, information communication. Anyway. This is where we combine tensile structures and shell structures, something Ferrauto also never did. So we're starting to say, okay, instead of having a tensile structure run off pylons, you have the tensile structure running off walls. This was our winning entry to the Tokyo Olympics. Couldn't make that. Or we have done something like this in large structures like the airport in Beijing. More recent projects. Grid shells, and again, you don't have to make them even grids, and this is, it's not fully optimized, etc. etc. Ferrauto. It's interesting. So here, this kind of path network optimization, but circulatory path, you can make the analogy to load path. So these become, you materially compute irregular load path networks onto irregular support points, for instance. So I did a project I was teaching at Harvard and did this kind of project for Google Campus, and one of the themes was using this and all the variation you can generate and translating into different materials, timber versions, and the smaller ones, steel versions, the larger ones. All sorts of shells in this way, double height, triple height, etc. Another team was doing grid shells, active bending. Another team was doing catenaries on catenaries. Inverted. and then differentiating out. So that's tectonism differentiating out. My conclusion at the end was this: each of these is intricate and beautiful and differentiated, but for a huge complex like Google Campus, where you have 25, 50,000 people and hundreds of various types of spaces and entrances, this is still too monotonous. But within tectonism, you can have all three and more systems coming in and differentiating out and layering. So I'm not happy with these. Up to a certain point, bring many systems and the variety together. That would be the ideal thing. And this Google Campus, as you can see, was interesting. We pitched heavily for Google and Larry Page and so on, and they just didn't understand what they're doing, because they said, we want somebody who's delivering a net zero. Okay, waste your whole company, 50,000 people waste their time because they're sitting in a net zero bunker. You really don't understand what you're doing. So. But then in the end, in the second round, they did something similar to this. They got Heatherwick and Bjarke Ingels doing the big shell and open space and so on. But they were still kind of made the same shell 3 times, so they still don't learn. This was an interesting tectonism project. The whole district, it was talking about unity across difference. This is not garbage spill, but it's very varied and intricate. That's the cultural district developed at the school in Vienna with the students for a new cultural district in Turkey. And different teams using very different principles of tectonics. Well, you can show you, they have tensile structures, they have grid structural framing networks, shell structures, conic, developable surfaces, etc. And it's quite intricate. If you go into detail, they're all quite different, yet they harmonize. They operate in parallel, observe each other, and they follow a single paradigm. That's my paradigm of the city development. Okay, this is another one. If you do topology optimization, you get an enormous amount of variety, and there are different tools. There are tools which erode the solid, which, maybe you can translate it into concrete, those which start with linear elements, and you can end up doing that, translating this into timber on steel. Different, even in this kind of optimization process, there are different packages and different sets of parameters. So it's an enormous variety. If you compare this to the traditional structural thinking, where you have 3 solutions, and here you have 300 solutions, which are distinct, but they're all optimization. Because what's the point of getting it down to the last 5%, right? Because you have lots of other things to think about. Expression, the kinds of spaces, the kind of materiality. So these are kind of projects we're doing with students, the whole of New London, and using this variety, using that. All of them have exoskeletons, atria, a lot of bridges. So this is something you can do if you come to work with me as a student, a whole city detailed to this level in 1 year. It's of course very long, because in the office we have to do this in 2 months. So. But that is a kind of but what's very important for us as firm, so we have done shells and tensile structures, parametric urbanism, topology optimization, tectonism, various ways of advancing, always using university, using this kind of post-professional degree. I've been teaching for 30 years at the AA, developing these themes. So before we did our first exoskeleton, we had 10 years of research at the school. Before we did our first shell and tensile, we had 10 years of research in Vienna and AA, etc., etc. The same happens now with the metaverse, happens with everything, happens with... Okay, so environmental logic, we earlier on started. So when you do, and I love the aspects of sustainability, which is about passive systems, for instance, shading, which is expressed on the outside. This starts with massing and volume configuration, self-shading, etc. you exploit, but then it also sun exposure, and you can run a sun exposure map and script a geometry translation directly onto this. So you can translate degree of sun exposure into density of louvering. And of course, there could be 100 different systems. And you can run them, and then you put another building in, self-shading, these things thin out. And when you look at the building, you know, there must be something here. And in an overcast day, you can see where south, west, east, north. So it's a lot of things. So this is a project we're doing. It's the central bank of Iraq on the Tigris. And here we try to combine the double constraint, structure and shading, brise-soleil, in these vertical elements. There's a big atrium in front, so you move up, you can see the city, and you interconnect between levels. But what is beautiful, so it ties up, there's a gold vault in the bottom, and then you have the offices, and then there is a podium where the atrium, the light and path connects up with the atrium. So there's also this kind of articulation of a path. Wayfinding, you can see how this looks very different from different sides. So it becomes like a sundial, or let's say, you know, and is also in the Middle East very hot, that you can cut out the heat. But it also is, so there is no justification to have a tower symmetrical all around. It's irrational, but it's a wrong default. We have said long, it's taboo. We still do it sometimes, I'm sorry to say, but, you know, but it shouldn't. It should be taboo. Some people decide to put louvers on their facades. How are they going to do it? They wrap it all on sides. It's insane. Instead, it needs to be optimized and differentiated. So this is another one of our flagship environmental engineering. And what I like about it gives character, identity to the place, to the project. You sense it's in that climate, in that region. This is a research center in Riyadh. So it's very heavily on small windows, deep cut facades, but it still wants to catch a lot of light from where the sun is not hitting into it, and it wants to catch wind. And so we did the volumes and the shading canopies have a related geometry. It's all based on hexagon, but not repeated hexagon which squeezes and pulls. And the hexagon has 6 sides to connect instead of 4, so it's more communicative and connective. And you can see here, this is where you don't get so much direct sunlight, but you get the wind coming in. And what is beautiful about this, you have the solid part and the tensile part. They follow the same environmental parameters. They orient their oculi in the same way. So you get system resonances, correlation. And that's the beauty of it. And then you have outdoor courtyards, you have indoor atriums, and you have these very different situations. They're different and similar. Why are they similar? Because they're driven by the same parameter logics. And if you now make many more different buildings around, and they all heavily articulate these, let's say, environmental logics, it's a unifying force, which we don't actually do in reality, because the discipline remains extremely unsophisticated. You know, it's as if you wanted to write a typewriter with your fists. Your tools are crude. Your tools, our repertoire, are so crude that you can only do very primitive things, which, you know, you wouldn't, it's like, you know, a surgeon coming in with you and cutting you up with a ruler and circle, you know. I think there's something which becomes intuitive appealing to people. It's very loved and used for public events. It's 21st century, unmistakably. It's original, it's new, it's fresh, and it's still Arabic. It's still embedded in the tradition. You know, certain typologies, like courtyard typologies, and the environmental kind of affiliation, etc. So I'm just racing through this. And the modernists got this right. This was before air conditioning. You had much more expressive. After air conditioning, what you get? Mirror glass boxes spreading around the world. This is Le Corbusier. We've done that, and this is how we look at this and how we do our translations of this. This is Brasilia. We now do this, of course, in a way which is varied. In the south, you have emphasizing the horizontal louvers. They can thin out to the north, and then they become extruded in the west. They become vertical because the sun hits very flat. So you get this kind of transformation of the different sides. And you sense it on the inside. You know where you are. This is a building just finished in Prague. Instead of learning from, these are our projects where we're learning to work heavily with deep relief, with various types of brise-soleilling. There's multiple levels. There's the main ribs, there's the secondary, and then there's a grill which is also pleat directional. So in some spaces, when to the north, you can look out and see the sky, but there's never a direct light coming in the daylight gallery. This is a proposal we did for Budapest, blob, with this kind of shading, intense densification, and degrees of extrusion. But then also formal affiliations that you're framing a surface with a backdrop, so you can make formally similar, because you have many ways of doing louvers, and many ways of doing lights. So they could also share and participate in generating a space. So it's not pure engineering. It's engineering as a constraint, driving and then composing a space. There's a big difference. You know, engineering is our input. We are orchestrating engineering options into a composition. The more exposed facade becomes to the exterior, and then it shallows out to the interior, but this also then tells you public-private. So there's information. You can use these details to characterize spaces. Oop. This is a simple idea of system differentiation, never repeat, but self-similar and parametric variability within a parametric element, parametric components. This is a default. If you do a system, which parameters do you give it? Which variability do you give it? What is it driving? What is it relating to? And so the default is never repetition. It's always variation. It's very rarely that repetition is the optimal solution. Particularly if you have a curved building. For sun exposure, it gradually changes as the degree. Undercut is different from exposure, etc., etc. These are very old projects. But we've built this. And you can express larger open spaces to the exterior. So there's a legibility to the exterior as well. And integrating podium and tower potentially. tensile elements. There's many variations, studies, and options of all of this. So, shell structures, super high performance concrete, mushroom shells, and clear foil as a facade. You open it with a zipper. It's a house I was designing for myself in China, but never happened. Timber, roof overhangs as well, climatic, tropical climates. You can also affiliate to traditional tectonics of the region. So some of our Middle Eastern projects look Middle Eastern, climatic, but also typology, morphology, materials. Some of our Chinese projects gain a kind of 21st century China character. I was asked, yesterday, how about this? There's something you can learn from those regions and features. But also, not only that you have relief and depth, this is just light and shadow studies, how a building, the character facade could be very different at different times of the day. It's the same building. Or this, which I'm talking about, observer dependence, parameters based on the observer positions. So if you can also do this when you want to, from different perspective, it appears differently. This is look at what happens. So only camera is changing. It shifts from a grid to a circle packing. It's the same architecture, depending where you look at it. You can affiliate it, you can make something homogeneous or differentiated. Affiliate that sent to something else on the other side, etc. Looks either wave, circle packing, grid, depending on point of view. But this is the opposite. It seems in the top view as circles, but then the circles disappear into a grid, into a wave. So that's another topic. I'm not going too deep into this, but those are called phenomenology. So investigating the morphology with respect to perspectival positions. So also some kind of effects like this. The entrances here, where we accumulate depths in the facade. This is student work. So it's, again, this is a team in 1 year, they can generate use balconies as shading and or louvers, etc., including the self-shading is integrated. And you can see the shift also from horizontal to vertical like we discussed. Another team. Shallow to deep depending on site. Sun exposure translated into geometry. So you get kind of these kind of visions for dense urban cluster. Okay. Fabrication. We've done a lot of recent, I'm not sure how you do it here, but the last 15 years there's also been a lot of investment in studios, student studios, master degree students, particularly at the Bartlett, for instance, also at DRL, about experimenting with fabrication, pushing the industry, like pushing the engineers as well with the tool making, as well in building extruders, hot wire cutting, all sorts of robotic fabrication technologies. And in Stuttgart they're doing it a lot, carbon fiber weaving and threading, and you get these wonderful different experimental structures. You use inflation and then robotic carbon fiber laying cells, a difference. This is wonderful stuff. This is not only us. This is also, connected to ex-students, etc. Aggregation of elements, minimal surfaces, but the fabricating with kind of aggregating small elements, super thin elements. This is our own material, super thin shell, robotically folded. So this curved folding, the robot creases and then folds these elements, which then aggregate into a super thin millimeter aluminum shell. We showed at the Venice Biennale. And then everything becomes part of an ornament as well. So we don't mind the bolting on, and they also enhance the kind of richness of the surface. 3D printing, we have an exhibition at our gallery where we also hosting lots of young talent and experimental work in tensile structures, hot wire cutting. So if you do these molds with milling the polystyrene versus hot wire cutting, it's about kind of 30 times faster and with hot wire cutting. But then you have to live with these geometries, but they're actually quite lovely. So they're all kind of ruled surfaces. And I mean, there are others studying this. You have kind of digital tectonics, 3D printed tectonics, etc., etc. So the enhanced tectonism for me is that it's not only technical. I'm emphasizing the communication aspect. You can see and learn what's happening, the natural differentiation of the structure. You look out that it's conspicuous enough. You look out for legibility. You look out for orchestrating the different systems to have both similarity and contrast, where you want contrast. So that's the thing. You look at all these technologies as a palette, a painter's palette, but a painter with a purpose. The purpose is to kind of paint the social picture so everybody can understand where they are, to make transparent the complex social institutions, and that's the idea. And some of it comes natural. So some of this, if you run script and you run, tension translated into density of points, run a networking script, and you can see where the forces are accumulating. And you can, if you're in the elevator and you remember where the floor you're on, you can say, I must be somewhere up high, or I'm quite low. So there's always something telling you. Whereas modernist repetition is incredibly disorienting. Row houses. You're coming home in the evening, you have to concentrate. Where's my home? You can't find even your own home every single evening because they're all the same. In Brasilia, which building is it where I'm working? So which floor am I on? I mean, there are two things which are incredibly disorienting. Repetition, particularly isotropic. If the grid is equal in all directions, which direction am I going? Symmetry breaking is good. At least I know I'm either on the north-south in Manhattan. I still don't know whether I'm north and south, but I'm not either north or south. I'm not going to be east-west. So it's better to also differentiate this. So symmetry breaking equals information. That's information theory. But the other problem is, of course, visual chaos, the garbage spill. Repetition and garbage spill are equally lacking of information. So it's menacing in a world where you have to continuously move from one place to another and meet new people in different places. And then you have to kind of look at the GPS blue dot. But then you don't see what's going on. You miss out everything you wanted to be. So these kind of logics, we can then kind of run the script. Okay, then at a certain degree of density, I can flip into, make these openings. Then I have running a core through this. And when you then run, the core is differentially far from the surface. If you then run ribs from the core to the surface and let them taper, they're differently thick when they taper back. So when you have a deep beam at the core, you know in this direction the space is deeper. If it comes back, it always starts from zero. It's shallow. So basically the structure will tell you in which direction is the largest spatial expanse. So everything in this correlated world becomes a piece of information for other things. I call it inference potential. It's very important. That comes naturally with parametric modeling. So you can see that here with these ribs very far, deeper, very close, very shallower. And but these are also have an inherent elegance and beauty if you optimize like this. And then you put an external surface on it, and this is kind of this orchestration of the elements. I think is very satisfying, and it nearly comes natural. But we still should then track and make conspicuous and orchestrate the visual correlations, etc. So, so what is interesting about these experiments, there's a kind of network of similarities. You can orchestrate it saying, okay, I have different timber structures, so they're different and yet similar in this way, but they're also similar here because it's from the geometry to geometry, but the material is different. Material is different and similar geometry, different geometry, similar materials. You can make a network of what belongs to what in a complex network. That's the way we can use this sociologically. And when we're coming to the kind of ordering of society, this was the first kind of ordering. Just make a loop, enclose something against the rest, and then have series of nested sub-enclosures. So it's this enclosures with enclosures and the subdivision logic. That was, for most of history, was the only ordering. Overlap, as I said, is very important, came in very, very late, in the 70s, or theoretically in the early 60s. And I showed this earlier. So if you look at the history of settlements, there's always this nesting thing. It's very important because without settlement structures, you could not have a social organism. You couldn't move from the animal kingdom into the human world because the human world is about a structured, larger groups, hundreds and thousands. You need to recognize them through where they are. They need to be placed and relate. And all the activities you have together in various subgroups need to be laid out so you can find them. And it's a memory structure and accumulates and grows with the society. But also, very important is this. And that's the importance of semiology. There's no human society which doesn't have settlement structures which structure the social organism, and where they have graphic transformation to distinguish different characters. Hierarchy, social group affiliation, male, female, married, unmarried. Without this, you couldn't have an ordered social life. And as I said earlier, it's very important, the fashion system, when you go into a room, you know, who is the boss? Where are the engineers? Where are the investors? And so you have this laying out the kind of cooperative organism, but you also have the graphic overlay, because at this point you have maybe the physical options of making structures are too similar to represent the social differences, so you need to start putting the graphics on yourselves and onto the buildings. There is no society which doesn't have this ornamentation either on themselves or on their environments. And it matters because these tribes are bone-breakingly poor. They're on the edge of survival, but they're investing in all this ornamentation. And to this day, if you reflect how much you pay on your wardrobe, of your annual income, this is vital. No society could survive. Those tribes which didn't do this had no chance of survival because they have kind of social ordering dysfunctionality. It's universal. But also to ordering the space, to kind of, if you don't do this, you will have physical, hierarchical battles continuously, or social ordering problems continuously. But also, friend and foe distinction, whatever or hierarchy, professional, occupational. It used to be extremely rigid. Now we can fit. But this was policed, of course. You're going to feed choice in what you're wearing and how you ornament your house. But it's absolutely universal. It only exists still in institutions which are extremely important and extremely tense. Everybody in their place, social, locational semiology, and this. They still do that in England. They work. Even the barristers wear robes and so on. But that's why we're also working on this. I'm working on tectonism, 21st century dinner jacket, super light, stretchy. I can run with it. It's breathing. You have all sorts of technical issues. You have cooling fibers. You have movement management. Where is it stiff? Where is it flexible? Where is it breathing? Where is it absorbing moisture? And you could differentiate the thing. I didn't have that here. We did a whole kind of collection for sportswear, etc. And how do you change, transform in different pieces and recombine and so on and so forth. And so we did a lot of that because it's important, and the semiology goes through fashion, interiors, furniture, architecture, urbanism, everything. So it's really always been going on that you had, the piano nobile, the kitchens and stables, the rustication. I mean, this is semiology. This is ornament. You want to express something, the fine, polished, the private quarters, etc., and different orders. Like I said earlier, the Doric Corinthian for different types of institutions. Theater is Corinthian. The kind of courthouse is Doric. So all this became kind of used. They used these tectonic systems to articulate, and it's a universal. And I want to show you this because to distinguish our task as architects, the way we use functional subsystems and engineering, and where we orchestrate to articulate the logic of an institution which enhances orientation and wayfinding. So this scheme is in the suburb of Strasbourg. It's 2 car parks, a tram station, and a bus station. So imagine in this kind of world, car parks, bus station, tram station, it would totally disappear in this kind of nowhere texture. But we created something which becomes conspicuous by doing a number of things. So these are the 2 car parks, but they belong together. So we tied it together across the street. And this is the roof, which is the tram station cutting in and the bus coming around. And it's tying it together. And we're using curvature to tie it together. So when the cars are sitting there and occupying they're also showing the way. So this is a kind of strong articulatory piece. And again, you make the cutout to show the tram, the bus. It's a park and ride scheme, something which would absolutely disappear in this kind of no man's land usually. Everything is technically perfect, but we're doing more. You can have a tarmac or concrete surface, and we use that strategically. So this is the kind of lines. And when we choose lighting, we wanted to use the street lights to work with and enhance the swarm of parking lines. To not clutter up with all sorts of random stuff. They align and work. They're growing in height the closer you come into the station. And then something reappears, the same formal affiliation. Then these things become similar to the columns. And the lines become similar to lights in the roof and cuts in the roof. So we're orchestrating. Nothing has a problem with functionality. We always have so many choices. So that in the end, what we choose, we orchestrate for formal compositional reasons. But formal compositional reasons are not just I'm an artist and I like this. This is formal compositional for legibility, for articulation, for communication, which is a fundamental core competency of architect. With no offense for the engineers, but those spaces where architects haven't done that, basements, backyards, where the spaces disintegrate into some kind of visual chaos. Because in a public space is okay, and the few people who live there, work there, doesn't matter. But that's the difference between architecture and engineering. Pure engineering would make technical choices to the last nth degree of cost and bolt things together, which are visually uncoordinated. That's the world of backyards and factory spaces and basement spaces. Now we need to realize that we can be technically and cost-wise within the 5% margin of that engineering. But we're generating, that's the difference between architecture and engineering. But it builds on engineering. And so this is a ceiling of this shed, and this is the floor. And the similarity comes out of they work together orienting. You can say, is it absurd formalism? No, there's a formalism in the sake of social functionality. And at night, there's this kind of swarm pulling you through. Okay. So that's this idea of semiology. And you can go further if you actually look at graphic systems in the street. This kind of idea of semiology, of encoding a visual language. We need it, we have it in the traffic. But traffic is relatively, because it's kind of safety, and you might make a crash and hurt yourself. But traffic is a very simplistic, primitive task of ordering social life. The world of our actual activities in the city and the institutions, at conferences, at universities, needs that kind of semiology much more. But I say it's a core competency of architecture. That's what we should be doing, like this park and ride. It's a very simple functionality as well. But we can do so much more. And we can, so there's a traffic sign system, there's a grammar. Each space should be a complex sign out of multiple affiliations, like a sentence with many words, making many connections to other sentences, etc. So here you're actually combining signs into a complex sign. It's not kind of each is unique. There is kind of red is, prohibitions, yellow is warnings, blue is must do. This is not allowed to do. And then there's the icons. They can iterate across these. Then there's the outer shape. So there's a number of components which come together. There's a kind of visual language. And we can do something similar in the world of design and architecture. And this is university design. You can color code initially on a diagram. But why not color code the real space as well? I'm coding it in a different way. And how they're kind of subdivided and connected and overlapping, etc. So we're doing this kind of, where we're saying we're doing something with shells. Shells give a nice unity. Where's a center, a space, rather than a flat. Shells give you, but also they still could be open and yet give you unity. There could be different, you could make a creased, a faceted, or a smooth shell. They more or less have similar shell action, so that it becomes a choice where you can encode the School of Science, the School of Art, the School of Humanities, if you like. And then have them across many different scales and variations. Then you have different things like lecture hall, library, workshop, seminar. They reoccur in all these different schools. So you can then run the different shells across these. So you have, 4 shells and 3, these kind of forms and 3 shells gives you already 3 times 4, 12 at least combinations. So you get a combinatoric logic. And then you can make combinations. You can combine by melding, you can connect through an interim, direct, one is dominant, the other is dominant. There's an algebra or grammar of connectivity of different types. You can also combine different shells, same shells, etc. You can nest them, overlap them, and articulate the diagram, functional diagram, let's say if you do think through the organization, you do a bubble diagram sometimes, right? And when you do them, you use curve. Why? Because you see the things properly. If you intersect two curves, it's easier to see the overlap as two rectangles. There's something about convexity, and when you then translate it into the final design, it's all rectilinear, it's all disappears. The legibility of the diagram gets degenerated. When you also have to tie it back, this doesn't fit into the side. So what's if you would kind of not degenerate the diagram, which for graphic reasons you make as articulate as possible so you can actually orient and see the ordering in the diagram. Why doesn't become the building the hyper diagram? It doesn't degenerate, but it keeps enhancing. And that's the idea here. So then you can have different tectonic articulations, there are different options, and you can re-affiliate again along different dimensions, so you have distinct outer shell, but similar reticulation, etc., etc. You can also transmute and morph from one into the other if you have a gradual transition. Instead of invented patterns, you can have topology optimization and network optimization. Anyway, and so you can generate something which generates variety, complexity, layeredness, and you can generate something which now looks complex, we don't understand it, but when in a space, you know where you are. You're in the overlap between these two faculties and the lobby between these three, between the workshop and the lecture hall, and this is the direction of the lecture hall, etc., etc. And you follow the trajectories. This is the kind of what project I'm talking about, the kind of using tectonism for semilogical articulation. This is the same with, diagramming, for instance, something like convex spaces are meeting zones of various scales. Concave vexes are working zones. But these two are distinguished from, they're still both closed versus open network of, these are open social and circulation spaces, but each is parametrically variable, so it could be many shapes. You can always track it's a working space, it's concave, they're always convex. You can then think about also morphing from one to the other, degrees of pure work, pure meeting. So you have parametric grammar, and you can then also see how they nest, meeting nest into work, work nest into work, overlap. Two work can generate a new work, two work can generate a meeting and a work can generate a meeting or work, etc., etc. So you can have a lot of options of articulating. And then we're going into 3D. We can also make it kinetic, and you can still legible at each state. And you can then have an overall color gradient, for instance, or an overall gradient from more closed zones and more open and fluid, where this kind of working spaces in the lobby, kind of quick work, en passé, meeting quick, so you can have them like this, semi-articulate, and then you can three-dimensionalize this. The same logic can be used for the furniture, so the concave form is a work desk, the convex form is the meeting desk. You can make them embedded in the open landscape and so on and so forth, and then you can animate it by bringing the crowds in. So this is the idea, that you can generate something which everything has an information. You can intuitive the language. Like any child, you can all learn a new language, you can learn lingual language. If you use it, you learn it. And therefore, everything, now to some extent, of course, environment gives you lots of clues. You intuitively know where you are and what's happening. But it's very stereotypical, it's not very nuanced. There's few categories. You know whether you're in an office building or residential, and sometimes even that gets obfuscated. There's 5 types of spaces. You know when you're in a corridor, but I want these kind of bleeding and in-betweening. For instance, if you go to Google Campus New York, the corridor is not just a corridor. There's lots of things that are going on. It's widened into a space, so there's lots of in-betweening, lots of subcategories. Ceilings high, ceilings low, carpet throwing in, quieter. we get some of these clues, but this is systematizing such a language to give you a lot of ordering and allow everybody to quickly, intuitively find each other, notice what's going on, where's to be expected. If I linger around here, who might come around, what might be happening, what is the social protocol inscribed here. We need this to be much more rich and nuanced. And I'm saying is that like a blind person can read the whole text by driving their finger along this dot matrix, we can go through a space and take in all of that and intuitively empowered. Yeah. Q&A, we have Q&As. You said it's open-ended. So now, what we're doing here is therefore different places, in this case they're similarly encoded, trigger different behaviors. You slow down if in a carpeted area, in the public space you're more quick. In the public space somebody is wanting to proxy you, talk to you, what do you want? In the private space you have to engage, hello, and this. So each type of space, the ambience tells you, puts you in a mood to be receptive, what is allowed, what is not allowed, what is expected. So this is what we're trying to do. And also when it reconfigures, there's new things possible. So what we're doing here, we're saying the meaning, the social meaning of the spaces is actually the behavior of those people. What should they do? How do they interact? Are they sitting down? Are they staying long? Are they moving through? This behavior is the meaning of these semiology. So we can bring the meaning and purpose, which is the same thing, into the design, and we should do that. So my challenge is this. If you draw a building or a piece of furniture, animate the purpose. What is this for? What could it be used for? Then you're an architect or designer. If you just draw the piece, then you're not a designer because you just draw something which can be measured, can be materialized, can be technically translated, but you don't test and investigate and imagine the purposes. Of course, if you only reproduce stereotypes, I mean, this is an interesting form. It changes and it's slightly amorphous. What is it? Well, the interesting thing is it could be many things. It could be a form. It could be an in-between situation. If you only draw stereotypes, of course, then you know what it is for. You only have 5 things. You know, this is a dining table. This is a working desk. This is a sofa. And that's it. Then, but you know, even in the 70s, when you had social revolution, you have sit-ins and all sorts of situation, you break out of these typologies, then you have to investigate what they mean, what they're for. And we're also doing empirical work, and then we are simulating, testing our environments, different kinds of groups, different teams, visitors. What might they do? What would they do? And you can encode their behavior. They're attracted by certain things. Different groups are attracted to different things. They have different protocols here. When there's somebody sitting down, you sit either close to it because it's a private space. Here you sit further away from it in this space, so it's encoded. And we can run this and simulate and optimize for social interaction. That's the idea. So we are saying every model, which is an architectural model, should have always the crowds running. And if you shift the sofa, new things happen. And if you re-encode the ceiling and says this belongs now to the private, different things happen. And if you want to coordinate thousands of people in hundreds of meeting rooms and zones and 50 entrances, and you want to test different differentiated types of agents, we can now run thousands of agents, then you can kind of say how many people will encounter each other, how many people will convert encounters and communications, will it be long communications, small communications, one-to-ones, larger groups, smaller groups. You can anticipate this, and when you can also design strange things. If you do this, you don't know what you're doing. You need to run and imagine and play it out. And so that's what we've been doing, and bringing the meaning and purpose into the geometry together, and also kinetic transformation, a big thing, that instead of having 100 spaces, you can transform one space into several things. That's very safe spacing, and it's not so distant. And you can help cajole and enhance and signal. A small group is forming, so more people can see and join or separate out, and walls opening up. So as a kind of dynamism, robotic, intelligent, architectural agents facilitate formation of social interactions or break it up if it's too long. And you can also have these zones, overlap, integration, furniture coming in, and dynamize the situation. So in the bureau, in the corporate environments where it matters, that you quickly move from one team to another, from one situation to another, small group, large groups, big gatherings, one-to-ones, concentrated work, and we even do the physical models of this. But then we're also testing it with agents. And that is really the meaning, that the social ordering effect and the kind of situations you can generate is what it's all about. You don't create an architecture for other architects and say, oh, nice ceiling. I mean, that's really not what we're about. You know, is it a systems of ceilings where this tells me and invites for a certain situation versus another? What is it similar to? What do I can remember and anticipate? The furniture tells me a lot of what can I do, who to expect, how to behave, can I join, can I not join? Body postures and filling out helps as well. So that's what it's all about. We are kind of for the lovely social life and productive social life, because you go to an event and you don't get it, you missed half of the event, you had 100 hellos but nobody to meet longer, or you got stuck next to somebody, you only had for 2 hours listened to this one person at that dinner table. I mean, you could have a horrible time in the wrong building with the wrong orchestration, so you can waste your time continuously, missing everything, get locked into meaningless conversation, never get beyond the kind of 1,000 meaningless hellos, and the conference was a waste of time. Or every day in work is a waste of time because we don't have the right intelligent environments, open yet intimate, dynamic, transformative, inviting, you know, deep vistas where you understand and see many things and you can get and guess what's going on, where to go. And this is this is all student work, let's say, and we also have professional versions of this, where you get these kind of deep spaces and they articulate and transformative, etc., etc. This should be your kind of world where you don't waste time, where you miss nothing, participate in the things you should be to participate. But you also and when you sit down on a certain table, you invite others to come. On another table to say, leave me alone. These gestures could be embedded in the space, in the architecture, in the transformation. And it's very important, otherwise you get disturbed every 5 minutes, or you sit there and nobody's joining you, misunderstanding the situation. So I've got, wait. We also do material experiment, how you transform spaces. This is with the same amount of particles, how you can various types of partitioning. This is important, there's a kind of physical substrate in which reconfigures. And that can imagine across the whole field. There could also be events and cascading through, radiating through, etc. But then bringing in, obviously, the end users to understand the situations. it's interesting to work through. I mean, they have many of those, but it also operates not on the furniture scale, it operates on the zonal and architectural scale. Also in the urbanism scale, these are different projects, so different teams relocate the project next to each other, they share zones, they're different yet similar. So there are many of these kind of studies. So in the end, the principle is, architectural models always have the meaning and purposes modeled at the same time. Not model only that geometry. That only makes sense if you can rely on stereotypes. But it also encompasses exterior spaces, public spaces. Now, this is research we're doing at the Design Research Lab in the AA. We then developed some of this modeling into PhDs. I have 4 PhDs on this, developing real thousands of agents, properly articulated, then have office internal research team, develop it further until we then kind of apply that as well. This is, by the way, Sperberg Technology Center. This kind of huge office landscape. There's 20,000 people, 20,000 square meters on a plate, thousands of people. The passages we actually elevate so you overlook and see people moving. Multiple atria in this building. And I'll show you later that we then run these simulations and test different configurations, not on the building scale, but on the furnishing and layout scale and corridor transformation scale. We then develop these kind of agents, different kind of characters, they have internal states, they have desires, they have a schedule of so much concentrated work, they should meet at least this much, who they should meet, maybe meet more people from a different discipline, across department, within department, across hierarchies, and then run these agents, thousands of agents, and cross different configurations, and then measure encounters and measure how encounters get converted into conversations, which might need a prop. You meet somebody at a corner, in a quiet place, or you can have a stand-up table, or if there's a sit-down, you generate longer conversations, but less frequent. So you can then kind of distribute this, and then you can kind of calibrate a mix of a range of situations, of types of communication, and you can quite specific set targets together with, let's say, organizational, managerial, let's say, demands and requests and desires for optimizing communication. So we can run this, and you can also visualize it and run individual agents, and you can run hundreds and thousands of agents simultaneously. And they are specific. They particularly belong to a particular department. We can input who they've been communicating, for instance, in their intranet, who they know, who they don't know, etc., etc. So that's what we're doing. And just to finally, we started to look at AI and the incompetence of AI with respect to tectonism. We're now kind of teaching tectonism to AI, so to have that palette to organize the semiological projects and run the simulations in a more enhanced and nuanced, articulated thing. So this is just where we started to teach and run, we training these neural networks to run structures onto an envelope. We can have particular tectonic articulations, saying fabrication logics. These are all rules, developable surfaces, so sheet, you can translate with sheet material, and you can embed that into the AI. with this degree of tectonic detail. Shell structures, and then bringing in more detail. So these are AI generated based on some what we trained up. So we're bringing in our repertoire, but we're also generating new synthetic training material. So this is, for instance, the tensile, the different tectonic materiality tags we learn, and when you then prompt back, you get this applied to the geometry. And so, you know, this 3D printing is a very intricate tectonism. And then this idea of the tower, I said earlier, we're translating between systems. You can do that, you know, also with tectonic system, but also material, concrete at the bottom into steel and then timber. And this is the public spaces, the office space, and the residential spaces as well. And that is something we developed, and this is not AI yet, this is something we then input. This is kind of a tectonism again. And then we've developed training up the AI of various topology optimized structures, where we actually generated the training data through topology optimization. This was a one-week workshop we did at Tongji with students. We gave later on a kind of massing model, and then we generated these topology optimization as training data, and the AI is generating them. Similarly with different types of fabrication details we inputted, and the AI is learning those for different components. And environmental models, we generate a lot of differentiated Brise-Soleil systems. And then trained the AI, and the AI is outputting that as well. So these are the three. And then you have to combine these prompts and generate the AI structures, and you generate these kind of systems. Look, they're very crude at the beginning, but at least there is some kind of beginning. And this is all the result of one, 5-week workshop at Tongji, where we're generating this learning, teaching tectonism to AI on that basis with synthetic data generated by the students, training up by the students under our guidance, and outputting the results and putting the results into some kind of massing model on site. And as short as this, so final chapter, very, very briefly, we are simulating on an urban scale with detail and interiors, where we put many of our buildings together. It's about 30 of our buildings, towers, museums, public spaces, blocks of various types. And I think my computer is at the end of its tether. That might. Okay, wait. It probably won't work. Okay, it's at the end of its. But so this is kind of where we are with the technology. Unreal Engine, it's a live model. You can jump in and roam around and meet with friends and show clients around, and move into the various spaces and get enough sense and photorealistic rendering real time for this kind of scenario. So, and in this case, not all our repertoire is yet tectonism. By the way, it's tough. Our output is, at least I would say, only 20% tectonism still. It's a learning curve, it's the opportunity, it's not, it's only segments and parts, but we're getting there. And I want to finally end on this. We also doing the metaverse and this idea of this intensive knowledge economy communication. In this case, it's a school of architecture hovering about London. It's connected to the AA. So virtual spaces have a similar kind of agenda, and we're also thinking about integrating virtual and real spaces. But I'll just show you this. This is a virtual Bauhaus, like an virtual extension of the AA hovering above the AA in London. And this is my latest iteration. Oh, is it? Sorry. It's a shame, because now it would show you how to go in. Let's see if that works. I have to disappoint you. Okay, let's just stop with this one here. There's another one. So I have these kind of 3 metaverse schools, which is a new topic, another lecture. You have to invite me back for the whole world of the metaverse, which I'm fascinated. But similar principles: intervisibility, inter-awareness, semiological encoding, many dynamic interactions, crowds in the virtual space, as well as in the. So this is a design school. Okay, so while this runs, this was the lecture. So if there's time, we can have a few Q&A.
Well, first of all, Patrik, thank you so much for such an insightful lecture. I was imagining like those who stayed with us until the end can go to AA and grab their diplomas straight away. Thank you so much. We've covered so many great topics, so I'm sure there must be a lot of questions, but just to be respectful with time, we can grab only a couple of them, please.
Thank you very much, Patrik. That was really fantastic projects. Yeah, I have a question. We know that after Second World War, there was a high demand for the architecture and the new vision. And I'm just thinking about what would be happen with the world when the parametrism was started in the 50s and 60s. And the following question is, what's the next after the technonism? Is there anything maybe like digitism, this similar thing, which is the data and etc.?
Well, I mean, I can see one possible transformation on the horizon. So usually, as I said, the architectural style fundamentally in epochal sense should only transform as there's a strong societal transformation. This glimpse of the metaverse is one thing. So if this is happening and absorbs more and more of our engagement, and it's all knowledge economy, we might transfer it into this realm, then you will move away. This becomes the primary realm for, real-time social interaction, communication, or at a parallel world. I think it will reconnect back, because we will sit here and have these surfaces which we communicate virtually, and we have virtual participants. But that could be a serious challenge to tectonism, because then there would be these kind of virtual opportunities and anti-gravity, anti-materiality articulations which would take over, which would radically transform the built environment. And if you have these windows into the virtual world, dominating the physical environment, then you will get a different kind of urbanism, architecture, etc. yet again. And but I see that world of the metaverse is coming, but it will be more subsidiary to the physical spaces. It will not dominate. They will be continuing the physical interaction spaces, will be virtually translated. So although it could also flip the other way. So that's the only thing on the horizon which I see. But as long as the physical interaction dominate, of course we can never get rid of that. But it could be less social. It could be more isolated, where you sit at home, get delivered food, and you only live in virtual worlds. That will be a huge challenge to architecture. So maybe that's coming, maybe not. Let's see.
Большое вам спасибо за тот волшебный мир, в котором мы побывали с вами.
Thank you so much for showing us this wonderful world we had a chance to see.
Да. Ну, вот действительно, все, что вы показали, очень большая работа, все это нас очень впечатлило, но вот не покидает такое ощущение, что вот параметризм уже стабилизировался.
Obviously, it takes a lot of work it requires a lot of work, but what do you think about parametricism not being stabilized yet?
Ну вот у меня вопрос. Как вы думаете, ждет ли нас вот в ближайшее будущее глобальная смена парадигмы в архитектуре? И вообще, будет ли это архитектурой?
Do you envision any major paradigm shift in the coming future in the architecture, or do you see it happening at all?
My view is this. So, as I mentioned here, so it's very difficult to predict societal, socioeconomic, technological revolutions. So I think in the 1930s and 40s, and even 50s, nobody could have imagined the world of the internet and global mobility, and what this would have done to our way of working and life. So, and architecture is following these societal and socioeconomic and technological transformations. And because those technological transformations are not predictable, the next stage of architecture is also not predictable. Now, but sometimes there is something on the horizon. Maybe in the 70s, some people who were working on computation could start to imagine the early time of the internet. People started to imagine already the metaverse, which might be happening in the next 10 years, but they imagine it in the 1980s. I was actually working on virtual college in the mid-90s. So some visionaries think they might see something. But I think mostly they might be wrong. In retrospect, since there were 1,000 ideas of the future, in retrospect, I think one guy had it right. But that is what I would see. So you can anticipate that. I said, for instance, I see the metaverse happening soon, and this might have an impact. And I can imagine what the impact on the architecture is. But as you can see, the problems, let's say the knowledge economy, the maximizing of communication, of interaction, of updating one's knowledge, of meeting and seeing many things, will still continue, whether it's in physical space or in virtual space. So there will be certain similarities, but there will also be dramatic differences. So I have an idea, but my confidence level is maybe 10%. So ultimately, I think we should be agnostic. But we still have to see what we do. So we cannot see the radical revolution which might be coming in 20, 30 years. But we can see the next 10, 20 years. And I think what I've been showing you here should be and could be the next 10, 20, 30 years. And it wouldn't be a waste, even if on top of this later on there's metaverse transformations on top. But it requires a certain stability of conditions. Yeah.
Thank you so much. Thank you. Unfortunately, we're run out of time, and we wanted to make a small present. As we're in Kazakhstan, we have this beautiful tradition of offering a small gift to Patrik. We hope you like it, and hopefully, yeah, please. It's a traditional coat in the Kazakh traditional style, please. And we would love to take a picture with all of us who stayed here. If you can just join us here, we would be happy to take a picture. Small note here, guys. After wrapping up, we would ask the audience to leave because there is going to be a media session. Adrian, could you please also stay? And we know that after this, there is going to be a strategic session with our important partners all along. And those who are involved in the session, please stay with us. Thank you so much, guys. Let's take a picture.